We're going to talk about today, Dr. Gallus did a nice job yesterday of setting up some of what I'll discuss here with these convection allowing or permitting models. Greg Carbon showed an example of the SSEO, and I'll kind of show that briefly. Basically, just a rundown of what we're going to talk about, and I'll jump into things right here. But John Wetter, who you've had the pleasure of hearing twice each morning to wake you up, is the person who's working with me on this, along with Hopkins Schools, which is where John works. So the convection allowing model basically is you run at a high enough resolution where you can turn off the convective scheme and get some realistic depictions of convective mode, development, and evolution. Dr. Gallus talked about some of the limitations and some of the issues, and part of why we're doing this and what we've seen from the SSEO is because different microphysics schemes and these different configurations can be good in some situations, bad in others. Using things through an ensemble framework where you have multiple solutions just maybe allows you to have a more diversity of things to look at and gives you a better overall maybe depiction of what expectations might be on a given day. So what do you already have access to in terms of runs that are out there that are operationally available run? Well, basically some of the things you have are the HWRF. I think everybody in here probably uses that, especially if you do any storm chasing. There's a run called the SPC WRF NMM. It's actually run at the Environmental Modeling Center at NCEP, but it got that tag on it many years ago because it was a run they specifically did to help out the folks at SPC before a lot of these runs became more common. Then there's these high resolution windows that are done a couple of times a day. There's sort of an eastern CONUS and a western CONUS domain. This part of the country is lucky because we fall within both of those, so we get access to those runs from 0 and 12Z, and the western domain is at 6Z. NSSL has a WRF run as well that you can get to online. The NAM actually, out of the 4 runs per day, within the NAM there is a 4-kilometer run. There's some settings on that where some of the fields don't have necessarily the same level of detail as these other convection allowing runs. There's that storm scale ensemble of opportunity, which essentially works to kind of combine a lot of these routinely available runs into an ensemble. And then there's what I'm going to talk about, which is this HopWRF, which is just, the Hop is Hopkins Public School, but it sounds cool, so that's what we decided to call it. But just in terms of ensembles, I mean, this is just a quick view of, the kind of information and how different, runs with just tweaking initial conditions or boundary conditions or some of these parameterizations can really give you a different signal. And this is just from a research run we did for the June 17th, 2010 outbreak, but I'm not going to dwell on that for too long. But when it comes to ensembling these convection allowing models, one of the big challenges is some of the traditional fields that we're used to looking at when we look at, say, the SREF or the larger scale ensembles, you can't really do at the storm scale. If you compute things like a probability off of these runs, and a run, they may be just slightly different, has a storm here, has a storm here, you try to create a probability from that, it's going to end up with lots of just patchwork. So what the folks at SPC have done with the storm scale ensemble of opportunities, they've done some of these things like these neighborhood approaches where they're making searches within a radius to do a lot of that stuff. So we're working on setting that up along with some of the more traditional means of doing ensembling. But this is an example of what's available from SPC. It's really good stuff. I've encouraged our staff to use it all the time. One of the downfalls or one of the negatives of it, though, is it is based basically once per day. It's a 0Z run sort of looking out through the day. And obviously things can change over time. So that's one of the things that was the impetus behind what we're doing. And I kind of just alluded to this, where you do these neighborhood and you look at these hourly maximum fields and things like that to tease out some additional details from these runs. And I'll show some examples of at least some of this so that it makes a little more sense. This is from what SPC has, and this is the big April 27th outbreak from a few years ago. And on here is just one of these neighborhood approaches, and this is just the probability of updraft Oliicity greater than 25, basically, within 40 kilometers of a point. And what it really highlighted in this case was a high probability of supercells in that area, and obviously you can see where the reports were. And then this was out of that same set of high resolution runs, just the hour or the maximum over the entire run duration of updraft Oliicity. So then you get some sense of where individual supercells within the model solution tracked through time during that event. What are we doing? Oh, once again, I can see this is where doing things on the Mac and then transferring. Something didn't fit in the box, but that's all right. So this is a collaboration basically with John Wetter and Hopkins Public Schools. And this is just some of the details, the technical details I won't go into. But I mean, they have a really good system there, and we're just carving off a small piece of it to borrow some of their resources to do these runs, basically. This is just some things, because you may wonder, well, why would a school department have any interest in doing this at all? You know, it's not like it's a meteorology program or anything like that. And this is just some information John gave me and things that why they're interested in it. One thing is they're simply interested in having more information on hazardous weather just from a safety standpoint. They also are, you know, affected to a large extent by transportation issues, so that's a big deal for them. And then they have a focus on STEM with the Hopkins School District, the science, technology, engineering, and math. So they're trying to get students more involved in thinking and looking at this, and having real-world application like this kind of helps in that process. And then this just sort of continues with some of the more things. I'm not going to read this all through, but you know, there's a focus within Minnesota on weather and climate, and it's part of the curriculum. So that focused in here as well. There was one particular event already where the school district actually on a day when many other schools had either went in late, John, or canceled. I can't remember.
They all closed.
Okay, they closed. And actually, based on some of the information from these runs, Hopkins chose to stay open, and it was the right decision. There really wasn't much in the way of snowfall in that particular event. So how are things configured? Basically, we do 4 runs. We have 4 members, so to speak. We have this outer grid here that's at a 20-kilometer grid spacing. And then inside of there is this area that's at 4 kilometers. So I do include the whole state of Iowa, so help out Carl, I guess, and folks down here a little bit. And we run every 3 hours. So every 3 hours, there's a new run that goes out 18 hours with these 4 members. The wrap is used for initial conditions in all of the runs. So we don't really change the initial conditions at all. But 2 of the runs, the boundary conditions are different. The NAM is used on one, and the GFS is used on one. Just an example graphic there of a 8-panel postage stamp, but some additional details. There's 45 levels. And essentially, this is how we get the different results. Is the microphysics, the boundary layer scheme, and the radiation schemes are all varied between the members. So that's where the differences are. If you go to the website, you can get the full details on what the different configuration options are, and I'll show those URLs at the end. For one of the members, I actually did include, there's an option within WRF to, in addition to the regular boundary layer schemes, you can also run a urban model. So there's essentially an urban canopy model within one of the members as well. For that outer grid, the 20-kilometer outer grid, all of them are using the KF convective parameterization on that grid, but of course the inner grid has no convective scheme. So an example here of just probability of cloud cover greater than 50%. This is just an example of one of the many things that you can pull up off of this. But for the 4 members, I call it the concurrent ensemble, the 4 members from any given run, they just get equal weighting in the various probability and mean fields that we do. But we also do a time-lagged ensemble where we use the current run and the 4 members from the run 3 hours previously. And I just arbitrarily give the current run a weighting of 1.5. I mean, there's no real science behind that other than saying the latest run should be a little bit better. This is what the website looks like. If you go to it, and there's output from individual members up here where you can look at just stuff from one specific member. There's also information on basically run-to-run comparison, so you can look at how has this member changed over the last 4 runs. And then down here is where we have all the ensemble products. So postage stamps, means, maxes, mins, probabilities. There's some plumes available on there. Those are basically site-specific time series plots. And spaghetti plots. Those aren't in there yet. I should have them done basically as soon as I get back to the office. So this would be everything from the concurrent run is kind of in this area for the ensemble products. And then the time-lagged information is over here where it's the current run and things from the previous run are factored in. Very quick example of a postage stamp. I think this is just sea level pressure and winds, but this is how the website's laid out. Basically, access to each one of the runs is over here. There's a pull-down menu, you make a selection, and then you can mouse over or animate. So fairly simple, easy to get to things. Some of the strengths, I think, you know, having on the storm scale, kind of as was spoken about yesterday, you do get some additional information on convective initiation, perhaps mode and evolution. The 3-hour updates can be helpful because obviously if things are changing in comparison to just having these runs maybe that initialized at 0Z, you get some additional information. And then obviously varying the physics and so forth gives you an array of possible solutions where perhaps one microphysics scheme, like was pointed out yesterday, maybe isn't particularly good at getting linear modes. Maybe another one is really good at it and, you know, does too much of it in the other direction, but by blending those things together, maybe gives you a better overall idea of how things might evolve. And then basically just having the time-lagged options just allows you to see how things are changing, maybe increases your confidence, things like that. Weaknesses, there's only 4 members. I'd run more if I could. We don't have, until I can get John to give me more CPUs. Kind of stuck with that. I'd like to have more initial and boundary condition uncertainty, but with 4 members, I'm focusing on the physics diversity at this point. The domain, obviously, we're limited by computing. Be nice to be bigger, but that's what we have. And then forecast projection, it's only 18 hours, but for the purposes of short-term nowcasting and things like that, that works out pretty well. So just very quickly, just to give you a flavor of what some of the output would look like, I just quickly have a couple of examples. One is from March, a cool season case. I did want to mention that we do keep a 10-day running archive. So if there's an event and you want to have, you'd like the images or the information saved off, I can go in and store that event. And then there's a warm season event. Well, the unfortunate thing is we haven't had anything this year yet. So I had to go back and do a rerun of a case from last year. So it's June 17th, but not the June 17th. This is just from 2012. So this March case, basically it was a 2-day winter storm event. We kind of had snowfall in 2 waves. One came on the 4th and the next on the 5th, and both were kind of focused around the morning rush hour time periods. But the large-scale models did fairly well with these systems, but didn't have the temporal or spatial detail for some of the things that we were looking for. So these runs actually were pretty beneficial in providing some of those additional details, especially in terms of when this lull in the precipitation would occur. And we really tried to convey that to the public in our products of, there's going to be a break. We have this 36-hour winter storm warning, but it's going to be sort of in 2 pieces. Just a quick loop of the entire event. This is kind of that first wave that we had on the 4th. And then that kind of goes away. We have some scattered stuff. And then this is the more significant time, was during the 5th into the morning hours, because that really lingered over the area for a while. And then this is just an example. This is what the postage stamps were showing. So this was for just the portion on the 4th, because once again, these runs only go out 18 hours. So this was kind of the helping us with that initial surge. So we see how we had the precipitation develop over the area during the morning hours, and then it starts to move out by the end of these runs here. But it kind of really showed us that around that time near rush hour, 10, 11, 12Z was really where things were getting going in the metro area, and that is how it worked out. So that was beneficial information in terms of impacts, because obviously snow at rush hour is a lot more meaningful than snow at 3 a.m. The second wave of the event, this is just an example of the mean reflectivity. So this is just taking the 4 members and just computing a simple mean. But this was for the portion of the event more so that went into the morning hours on the 5th. So you're not seeing the entire time frame here, but once again, it helped us with the location and the timing and just kind of refining some of the details for the forecast. And then this was not capturing the entire event once again, but capturing the main portion of it, which occurred on the 5th, and just total precipitation from the model. And I'm just going to toggle back and forth to the snowfall. The maps aren't quite the same, but you get the idea of the main areas of where the gradients were, the cutoff here in Wisconsin, and then in southwestern Minnesota, you can kind of see, help with kind of nailing where those areas were going to be in terms of where the precipitation was shutting off. Warm season event. This was more interesting in terms of it's the only time I've ever gone storm chasing. I make fun of storm chasers, sorry, but it's not my thing. But I went with John for this event. We didn't see any tornadoes, so I give John a lot of grief about that. But it was an interesting event. There were some tornadoes, just not where we were. There was a lot of hail, and there was wind. One of the funny things I'll mention when I show the radar loop here in a second, but basically, you initially had supercells. Eventually, it kind of transitioned into a linear system, and then eventually moved through the Twin Cities area later in the evening. Just things didn't quite line up. The best deep layer shear and low level shear weren't really coincident with each other. The better LCL heights weren't quite where you needed them, so things weren't perfect. I say see John Wetter for details, just I'll show you here in a second, but precipitation amounts maxed out between 2 and 4 inches for the event. And here we go. So this is a radar loop of this event, and I'll probably let this play through a couple of times. Initiation mainly out in South Dakota there. And then you can kind of see the evolution with time of discrete cells kind of merged, and then you had a linear system. And I'll point out where John and I were. We headed out in this area and waited for stuff to get going, and eventually we went on to these cells here. And then this thing just bowed out and chased us down the highway, which was the funny thing is when we got back later and we checked our email, we had an email from Al Patrica, who was watching John and I in GR Analyst looking at the place files because we were using Spotter Network. And he said he thought there was going to be a SUE opening in Minneapolis based on where we were when this thing started to bow out. So it was a little interesting for a few minutes there because there were high-end wind, there was 80-mile-an-hour type winds, so it was high-end straight-line wind. And you can see that in the SPC plots there. So this is just a postage stamp from the 4 members from basically the 12Z run that I did for that case. And overall, there's certainly some things that are wrong in here. A couple of the runs really wanted to develop activity in Iowa, which never happened. But the general evolution of things, when you kind of glance in terms of where things really got going, and then discrete cells lining out over time and then moving in through the Twin Cities. So it did a reasonably good job in capturing the overall evolution of things. Some of the unique products you can get out of these storm scale models are things like the updraft helicity. So this is the maximum updraft helicities over the run from the 4 different members. And what you really see here is the general consensus was if there was going to be a time with mesocyclones and supercells, it was mainly when the activity would be out over the Dakotas and western Minnesota, not so much when it would get into the eastern part of the state. And indeed, that's how things worked out. But none of this happened. You guys didn't see any of this activity in Iowa. So that once again, that's kind of where the ensemble framework comes in handy, because if all you had was this configuration in this particular event, that wouldn't have worked out well for you, but maybe in another event it would. And then this is sort of max run Groppel. So what this is trying to give you a sense of is the model producing a lot of hail with the system. So once again, showing mainly if there's a lot of hail potential, it was probably more in the initial phases before things turn more to wind. There's a lot of additional products on the website. There's a lot of other things you can look at, but I wanted to at least throw a few examples at you. Other things like I do, this is the mean, so this is the average sig-tor parameter, just a snapshot, but from 0 to Z. So you can see, it wasn't a prolific tornado producer, and well, the model didn't think it would be either. And then 0 to 6 kilometer shear, once again, this is a mean of the 4 members, showed the best shear out over the western part of the area, which is where you mainly did have your supercells. And then the best 0 to 1 kilometer shear from the model was showing mainly over the eastern part of the area, so things just weren't quite lined up the way you would have wanted them to be. And then the LCL heights, the favorable ones would basically be the bluer colors. They were okay out here, and the few tornado reports you did have were out in that area. As things went farther east, it was sort of saying, no, not so much. And then this was the actual observed, so to speak, precipitation from the event. This is the Q2 data, basically using radar and gauges where they're available. And that kind of maxes out from 2 to 4 inches as kind of the heaviest area. Now, these are the 4 different solutions for run total precip. This obviously did not happen, but the main thing you can get from these runs sometimes is what is the maximum it's producing? And the maximum that pretty much showed up in the runs was in that 2 to 4 inch range. So once again, maybe giving you some information on what's your max precip potential. Maybe not, the location's not perfect in any individual run, but overall at least is giving you what the signal is. A few other things I want to mention before I wrap up. I know everybody wants to get on the road. We've started to look at just who's coming to the site. This has only been up for a few months. Where people are coming from, a lot of our visitors are coming from Twitter and Facebook, some from Google+. We've had a lot of, basically referral traffic is about half, and then direct traffic, just people going straight to the site, is about the other half. Who's visiting? Well, mostly Minnesota, which isn't surprising. But for some reason, there's people coming from Kansas, and our domain doesn't even extend to Kansas, so I don't know what they're getting out of it, but it's good for them. And then it could be because our traffic gets routed through Central Region as well. That's probably part of that, although I would have expected that to show up in Missouri, not Kansas, so that was what confused me. And then just the thing I want to point out here is when we have events, we have spikes, just like anything. That's when the usage, when there is an event going on, people are coming and they're looking at it. And there is a lot of mobile use. iPad, iPhone, some Android devices are kind of some of the main mobile type devices that are accessing this information. Things we still need to do is some verification, subjective, and I'd like to do some objective verification. Perhaps adjust the weighting and the time lag once we have a sense of performance. Still some additional products we need to get onto the website. We're also going to set up a secondary website right on the Hopkins School server, which is probably going to become more of a project for students to work on, setting up those web pages. It'd be nice to add additional members, but it's all about computing. And I do put feedback in here because we want to hear. We want to know if people are using this information, if it's helpful, things like that. So I'll leave this up here. These are the various places, obviously the email addresses, the website for the ensemble, and then where we are on social media. So with that, I'll wrap up and take any questions.